a dot convention, a more difficult sum than a previous case. Difficult in terms of calculation, not in terms of concepts. So let's have a look, my dear friends. When I observe this network, the question says I need to obtain the voltage source across 5 ohms. Basic law. If I say about basic law, the Ohm's law, V is equal to IR. So when I say V is equal to IR, I already have my resistance, which still says if I need to find the voltage across 5 ohms, I just need to find the current. So if I talk about current, I just need to find the current across this loop. So if I cut the current across this loop, I can easily get the voltage across 5 ohms. So let's do it. I have two smaller loops in this. So the first one will be taken as I1, the second one will be taken as I2. The logic is that you cannot apply KVL when you have coupled points. So you need to replace it by a voltage source. That's the first point. So let's replace both the coupling by a voltage source. The voltage source will be in series with your inductor in both the cases. So let's do that. So your new network will be a voltage source plus some sinusoidal voltage source, 50 angle 0, again a dependent voltage source. This is obtained respect to this coupling, an inductor, a resistance, a capacitor. Again a dependent voltage source along with the inductor, then a resistance in series with it. This will be a 5 ohms, J 10 ohms, J 5 ohms. Now second question arises, you have already put down the voltage. What will be the sign convention? In this case, your inductor is in horizontal condition. So logic says, if it is on left or right. When I say left, I'm talking about the coupling points. The coupling points on the left or right, the sign convention will be plus minus. If it is a combination plus minus, minus plus, then the voltage sign will be minus plus. Again, let's repeat. When I say the sign convention of the voltage source, logic says if the coupling is on the left or right, then the voltage source should have plus minus. Since the above is on both are left. If it would be one left, one right, or one right, one left, it would be minus plus. Now second point is that what about the voltage value? The voltage value is given by the mutual coupling which is given to you. So that is J 5.66. This will be J 5.66. Now what is the difference among both the voltages, which will be now taken as in terms of current? When I say mutual coupling, I mean by this couple depend on this point, this couple depend on this point. When I say this is depending on this, in this point which current is flowing, you will say I2. So over here you will be writing as I2. And I talk about this voltage. This coupling is depending on this couple. So in this coupling point, which current is flowing? I1. So your voltage value will be I1. So this will be a circuit which you need to apply KVL. If you make mistakes in writing this voltage source, your whole sum will be wrong. So please make it sure about the voltage value. So now let's apply the KVL for the following loop. So in the first loop, you will be considering your current as I1. In your second loop, you will be considering your current as I2. Since you have two unknowns, my dear friend, and you have two loops, you will be applying a KVL in the following two meshes. So let's apply the KVL in the above meshes. So your first will be applying KVL in mesh 1. We get. Make sure you have drawn this diagram in your notebook so that in the further explanation it will be much easier for you, because the diagram won't be repeated in the further explanation. So now let's write the KVL equation for the above equation. about mesh equation. So add the real and imaginary parts. So the equation which you will be getting will be 3 plus j5. Your current will be I1. Since you're writing for mesh 1, the sign will be positive. So now you'll observe is among these two, is there any other current which is flowing? So you will say it, you have a current known as I2. If you observe I1, I1 is flowing across three terms. So there is one more term known as plus minus J4 I1. Any other current, so you will take a negative. So your value will be 3 minus J4 I2. Now we will be writing equal to. After equal to, there should be only voltage source. So you have two voltage source over here. One will be, if you enter into negative, it will be positive. If you enter into positive, it will be negative, vice versa. So all the variables should be on LHS side. Only on RHS there should be only constant. So shift everything. So you'll be getting 3 plus J5 minus J4 I1 minus 3 minus J4 bracket I2. Shift this side plus 5.66 I2 equal to 50 angle of 0. So take I2 as common, so you'll be getting 3 plus J1 I1 minus, take it in bracket, 3 minus J4 minus J.66 I2. Now don't think here it is positive, why I have taken negative. The reason is that since outside term you have a negative term, when you open the bracket, again you will be getting a positive term. So please make sure how it is negative. Okay. Next, so it will be 50 angle 0. Simplify this. So 3 plus J1, this will be I1 minus, this will be 3 minus J 9.66, this will be I2 equal to, it will be 50 angle 0. That will be your equation number 8. Now let's apply KVL in your mesh 2. So it will be applying KVL in mesh 2, we get. In mesh 2, you have 4 components, 2 resistance and 1 inductor and 1 capacitor. So addition would be 8 plus J10 minus J4. Your current flowing is I2. Since you're writing for mesh 2, the sign will be positive. Now observe among all the 4, is there any other current flowing apart from I2? So you will say yes, the term is 3 minus J4 and the current is I1, the sign will be negative. Equal to, on equal to there should be only voltages. So observe if there is only one voltage or not. So you'll observe keenly there is one dependent voltage and the current is entering clockwise in positive. The sign will be negative 5.66 I1. Shift that side, so you'll get minus 3 minus J4 I1. This will be plus J 5.66 I1 plus this will be 8 plus J6. This will be I2 equal to 0. I1, take it common. The term which you will be getting, my dear friend, over here it will be minus, take it common, 3 minus J4. Since outer part is minus, you have to change this sign. So it is plus, it will be minus J 5.66, take I1 as common, plus 8.J6 I2 equal to 0. Simplify this equation. So your next equation after simplified will be over here minus 3 minus J 9.66 I1 plus 8.J6 I2 equal to 0. My ultimate aim is to find voltage across 5 ohms. For voltage across 5 ohms, if I observe carefully, I need the current I2 into 5 ohms. So I need to find I2. So let's find the I2 current. For finding I2, in this format, let's write the value across this. This column is for I1, this column is for I2. When I say I need to find I2, the I2 column should be replaced by RHS. So in your first equation, your RHS was 50 angle 0. In your second equation, your RHS is 0. This part is nothing but coefficient of I1. So in your first equation, if you observe carefully, your coefficient of I1 is nothing but 3 plus G1. In second equation, your coefficient I1 is minus 3 minus 9.66. Again, at the denominator, in denominator there should be only coefficients of I1, I2 from equation number 1 and 2. So let's observe in equation number 1, the coefficient of I1 was 3 plus J1. Again I1 was minus 3 minus J 9.66. Coefficient of I2 was minus bracket 3 minus J 9.66. Coefficient of I2 in second equation was 8 plus J6. Simplify this equation by using a scientific calculator. It's very simple. So let's take an example how to simplify it. Put your mode in your complex since you have imaginary terms. So let's simplify the numerator part. When I say the numerator part, I put a bracket. This is numerator ka big bracket for numerator. So this multiply with this. So bracket, you got answer 0. Minus bracket. This multiply with this. So you'll get 50. Shift an angle 0. Bracket close. Again bracket for this. Outside you have a minus sign. So you'll write bracket minus 1 bracket 1 close. Then this term bracket 3 minus, this will be 9.66. While writing we did G first, but in calculator it is I afterwards. Close bracket. This bracket is closed. Now you have to close this bracket which you have opened. So your bracket will be closed. Then your bigger bracket for numerator. So the value which you click, that will be a value for numerator, which will be equal to, which you got 150 For imaginary part you have to press shift and equal to. So you got minus J 483. So let's do it for denominator. Big bracket for denominator. Let's multiply this and this term. Bracket. This will be 3 plus 1 I bracket close. Again multiply with this term. 8 plus 6 I bracket close. Bigger bracket close. So this is your first part, right? Put the minus sign. Bracket. Minus minus this will be plus. So in between you will be having minus sign. Multiply. Minus 9.66 I. Again 3 minus 9.66 I bracket, big bracket close. So your denominator will be, there has to be some error with respect to the value. Let's do it once again. Bracket. You had 3 plus 1 I bracket close bracket. This was 8 plus 6 I bracket close minus, again this minus will be positive. So multiply with this term. 3 minus 9.66 I bracket close. Again 3 minus 9.66 I bracket close. So your value will be 102.31. Shift n equal to, for imaginary part, will be plus J 83.96. In calculator the I is after the number, while writing you have to write the J term before the number. So please make that sure. So now divide both the term, you will get the value for I2. Bracket, your numerator is 150 minus 483 I bracket close. Divide by, open bracket, it will be 102.31 plus 83.96 I bracket close. So that will be a value for numerator, and your value for numerator is minus 1.43. That's a real value. So value for numerator will be minus 1.43. Shift n equal to, the value will be minus 3.54 J. So this will be minus 3.54 J. That's the value for numerator. This is in a rectangular form. If you want to convert into polar form, the conversion is in this format. So your calculation should be in complex mode, right? So the value is minus 1.43 minus 3.54 I. If you need to convert to polar, you have to press shift and plus. If you can see above the plus, you have a POL sign, polar sign, shift and plus. So you'll get R and theta. So the value for R is 3.81 angle. For angle, you have to press shift and equal to, the angle is minus 1111.99. So it is minus 1111.99 amperes. So after finding the value for I2, ultimately the our aim was to find the voltage across 5 ohms. The formula was nothing but I into R. For I, you had I2. For R, you had 5 ohms. So multiply your current of I2, 3.81 minus 111.99 into 5. There is no rule that you have to bring this into polar form. Even if you keep it into rectangular form, it is right. Only for your understanding how to convert into rectangular to polar, that's the reason we did it. Okay? So there is no requirement that you have to put that term into polar form. So let's do it. Multiply voltage across 5 ohms will be, multiply this polar form into 5. So value will be bracket 3.81 shift and angle minus 1111.99 bracket close into open bracket 5 bracket close. So value will be minus 7.13 shift n equal to, value will be minus j 17.66. The value which you got is your rectangular form. Always whenever you calculate into complex form, you'll always get the value into rectangular form. You'll never get the value directly into polar form. You have to convert that value into polar form. So let's convert the above value of rectangular into polar form. So the logic will be bracket minus 7.13 minus 17.66 I bracket close shift and polar. You'll get the value for R. Value for R is 19.04. Angle will be, that is minus 111.98. In both the cases, the unit will be volts. So that's what first question has been asked. Find the value across 5 ohms. So let's take one more example to understand a better concept for a dot convention. Signing off. Thank you so much.